Welcome to your Algebra 2 lesson, 3.8, Video 1. Today we're going to solve linear systems using inverse matrices. So our objective overall is that you will solve linear systems using inverse matrices, but the first thing we have to do is define an inverse. And before even that, we've got to talk about the identity matrix. An identity matrix is a square matrix with ones running down the main diagonal. Remember, that's the upper left to lower right, and 0 elsewhere, and it's denoted with as I. The product of I and any square matrix A of the same dimensions is A, regardless of order. And that's why it's called the identity matrix, because it preserves the identity of the other matrix. So for a 2 by 2 matrix, it is the matrix 1, 0, 0, 1. And then for 3 by 3, it's 1, 0, 0, 0, 1, 0, 0, 0, 1, and then the pattern continues from there. When two square matrices multiply to equal their corresponding identity matrix, the two square matrices are inverses of each other. The symbol for the inverse of A is A, and then to the power, it looks like an exponent of -1. So that, but it's read A inverse. All right, so let's define an inverse of a 2 by 2 square matrix. There's a nice little formula that's not too bad to use. Again, I'm not going to require you to memorize this. I'm going to give you the formula. You just have to be able to use it. The inverse of a 2 by 2 square matrix, A, B, C, D. A 2 by 2 square matrix has an inverse if AD minus BC is not equal to 0. The inverse of a matrix A, B, C, D, is A inverse equals 1 over AD minus BC times D negative B negative CA. So on the main axis, or the main diagonal, you swap the two elements, D and A change places. On the minor diagonal, B and C stay where they're at, but they change signs. And it has to be where AD minus BC is not equal to 0. Otherwise, that coefficient up front is undefined, and so you don't have an inverse. So, first thing, before we get into solving a matrix equation in the form AX equals B, which we will get to in this lesson, we're going to go work a couple of examples just working with inverses themselves. Okay. First thing we're going to do is find the inverse of A equals 3, 8, 2, 5. Nice little 2 by 2 matrix. So 3 is little a, 8 is little b, 2 is little c, and 5 is little d. And so using our formula, A inverse is going to equal 1 over AD minus BC. So AD is 3 times 5, so that gives us the 15, minus BC, that's going to be -2 times -8, and so that gives us the 16. And then we change the square matrix. We switch out the A and the D, and so 5 is going to be in the upper left-hand corner, and 3 is going to be in the lower right-hand corner. And then for the 8 and the 2, we just change the sign. So we have -8, -2. 15 minus 16 is -1, and 1 divided by -1 is -1. So we've got -1 times 5, -8, -2, 3. Multiply each of the elements by -1, and we get -5, 8, 2, -3. Okay. So now we're going to talk about solving a matrix equation in the form AX equals B. Now, what's going on here is that A is multiplying X, and we want to solve for X. Normally, we would divide both sides by A. If we were just working with numbers, that's what we would do. But in matrices, division's not defined. So the way we approach it is we multiply on the left by A inverse. A inverse times A is going to give us I times X. And then on the other side of the equation, we have to multiply by A inverse. So we're going to have A inverse times B. So we have the identity matrix times X equals A inverse times B. The identity matrix times X is always X. So X equals A inverse times B. And that's what you need to know. If you can write the equation in the form AX equals B, then X is going to equal A inverse times B. Okay. We want to do example 2 right now. We're going to solve the matrix equation AX equals B for the 2 by 2 matrix X. And so we've got A, our matrix A is 2, -7, -1, 4 times matrix X equals -21, 3, 12, -2. So we've got our A matrix and our B matrix. So X is going to equal A inverse times B. So the first thing we're going to do is find the inverse of A. So A inverse is going to be 1 over 2 times 4 is 8 minus -1 times -7 is 7. We're going to swap out the 2 and the 4, so it's now along the main diagonal. We have 4, 2, and we're going to change the signs along the minor diagonal. So in the upper right-hand corner, we have 7, because -7 is +7. And then in the lower left-hand corner, we do the opposite of -1, and so we have 1. 8 minus 7 is +1. 1 over 1 is just 1. And when you multiply 1 times each of those elements, they don't change. So we've got 4, 7, 1, 2. To solve the equation for X, multiply both sides of the equation by A inverse on the left. So we're going to do A inverse times AX equals A inverse times B. So we've got 4, 7, 1, 2 times 2, -7, -1, 4 times X. And then we've got 4, 7, 1, 2 times -21, 3, 12, -2. Okay, so now we want to do our multiplication. So if we do the A inverse times A, we're going to end up with I. So if you look, 4 times 2 is 8 plus 7 times -1, 8 plus -7 is going to be 1. And then 4 times -7 is -28, plus 7 times 4 is 28. Those add up to be 0. And then we go down to the second row. 1 times 2 is 2, plus 2 times -1 is 2 plus -2. We get 0. And then 1 times -7 is -7, plus 2 times 4 is 8. -7 plus 8 is 1. So we end up with that identity matrix on to the left of X, which is what we wanted. On the right, we have to multiply the 4, 7, 1, 2 times the -21, 3, 12, -2. So 4 times -21 is -84, plus 7 times 12 is also 84. -84 plus 84 is 0. And then we do 4 times 3 is 12, plus 7 times -2 is -14. 12 plus -14 is -2. And then we move on to the second row. 1 times -21 is -21, plus 2 times 12 is 24, and so those add to be 3. And then 1 times 3 is 3, plus 2 times -2 is -4. 3 plus -4 is -1. Okay. I times X, the identity matrix times X is just X. It's the whole point of it being the identity matrix and why we went through the whole process. And X equals 0, -2, 3, -1. So that is our solution. That is our solution to our matrix equation. Okay, that's going to be it for video 1. Meet me back here in a minute for video 2. And we will finish up.